All right, you guys, so we are going to be looking at systems of equations. So Unit 1 in Math 3 jumps around. The topics don't necessarily relate to one another in a way that I would consider to be great, but it's not entirely up to me. So, um, what we're going to do here is we're going to review something really quickly that you have done in a prior class, and then we're going to expand on it with a bunch of different other functions. So right now, we're just going to look at systems of linear equations. So these are lines, okay? And if you notice here, we have 3 answer choices, okay? And we always have 3 answer choices when it comes to systems of equations. All right, so why I love Desmos. You do not have to solve it for y. You're going to type it in. You're going to type the first equation in, type the second equation in. You do not have to rewrite it. And you press the home button. Okay? All right. Now, you might have to zoom in and zoom out. It's not always perfect, and you'll see that these graphs can get pretty messy as we introduce other functions. But if I click off the blue line, there's the red line. If I click the blue line, okay, the blue line is right on top of the red line. And if you remember from Math 1 and Math 2, when they are the same line, the answer is infinitely many solutions. Okay, so I'm going to submit. Yes, and you can see here is the algebraic approach. Okay, that's the approach we are skipping for right now, and we are solving it graphically. Okay, now let's just look at tables. So if anyone were to ask you about the table, okay, you cannot switch it into a table unless you solve for y. Okay, so that is going to be the only part that is not that great. But if I click done, all right, so y equals 5x minus 2. And since it's the same one, y equals 5x minus 2, that's the same, both of those equations have been solved for y. But if I click here, see how the table pops up? Okay, and then you could see the table of values. And if I were to convert this one, if I was able to convert it to a table, it'd be the exact same table. So just know that you'd have 2 tables that are exactly the same. Okay, all right, let's look at a new problem. Okay, all right, so 6x plus y equals -9, and then negative 30x minus 4y equals 55. Okay, now this is the part where you can see where I'm not a huge fan of Desmos, because when these lines are really, really close, okay, but you can see, okay, they intersect at one point. And if I were to zoom in, okay, even then it's not perfect, but when you click on it, okay, where they cross pops up. So you can see they intersect at one point, and that is one solution. Okay, and then if we wanted to determine that exact solution, that's the exact solution. But in terms of a generic approach, it's one solution. Okay, I need to submit my answer. Yes. Okay, and again, there's the algebraic approach. Okay, new problem. All right, so we're not going to do that one because I can already tell. I need to, there we go. Oh, I missed it. Okay. Sorry, I needed to get the right example up because I need you to see the third one. So negative x plus 2y equals -8. And then negative 5x plus 10y equals -30. Then I'll press the home button. Okay. All right. So I needed this particular picture, and that's why you saw me click through a couple things on the right-hand side. Okay. The reason I wanted this picture was because they're parallel. Okay. So when the 2 lines are parallel, the answer is no solution. Okay. All right. And so just to recap, okay, infinitely many solutions. That's when you have the same line. So when you type this into Desmos, you get one line. Okay, that's infinitely many solutions. One solution, that's where the two lines cross. Okay, so they'd make some kind of funky X. Okay, because they intersect at one spot. Okay, if the lines are parallel, okay, the lines are parallel, the answer is no solutions. Now that should all be a reminder, okay? But that's what we're going to be looking at now is when we do systems of solutions or systems of equations, sorry, okay? We're going to be looking for where our equations cross or where maybe they don't cross or if they are secretly the same problem given to us twice and so there's infinitely many solutions, okay? All right, so come back for video number 2.